Dynamic data access shouldn't require custom client code for every API, database, or file system. What if you could use the same 2 lines of code for all of them? We'll demonstrate FastMCP's unified resource system, where a single read resource call handles everything from custom protocols like weather, //London/current to standard file paths. You'll see how the client resolves these URIs against server-registered templates, configured via @MCP. Resource decorators, while the server manages the actual data fetching, whether it's hitting a weather API, querying a database, or reading a file. The pattern stays identical across all resource types, with the client always receiving results in a documented list format.
Async with client. Hash read a resource generated from a template. Hash, for example, a template like weather //city/current. Weather content equals await client read resource weather //London/current. Hash access the generated content. Print weather content 0. Text hash assuming text JSON response.
This demonstrates FastMCP's uniform resource access pattern, where all data sources, static files, dynamic APIs, or database queries are exposed through standardized URI templates. Servers register resource templates using @MCP, resource decorators, defining parameterized endpoints like weather, //city/current that generate content dynamically. The pattern's distinctive feature is that clients interact with concrete URIs, while servers handle parameter extraction and content generation transparently during the MCP handshake. The approach works through protocol-level capability negotiation during client initialization. When a client connects, servers declare their supported resource templates and URI schemes through the MCP handshake. Clients then request resources using complete URIs, such as weather //London/current, and the framework routes these to the appropriate server, extracts parameters, and returns standardized content containers, always as lists, even for single resources. This design enforces consistent access patterns whether working with file //config/settings, database //users/123, or custom protocol URIs, while keeping client code protocol agnostic. This matters because it creates a single abstraction for heterogeneous data sources across multiple servers. The trade-off of server-side template implementation enables powerful features: multi-server routing, where weather // and resource // prefixes automatically dispatch to different servers, type-safe parameter handling through URI templates, and unified access to both static and dynamic content. The same pattern extends to tools and prompts, using call tool and get prompt, with identical URI-based resolution, making FastMCP's resource system a foundational building block for larger applications. Let's break it down line by line.
Async with client.
Async Context Manager for FastMCP Client Lifecycle handles connection initialization with server capability handshake and ensures proper resource cleanup. The client's configuration maps URI prefixes like weather // to specific servers, enabling uniform access to templated resources across different protocols.
Hash read a resource generated from a template. Hash, for example, a template like weather //city/current. Weather content equals await client read resource weather //London/current.
This uses FastMCP's URI template system, where servers expose dynamic endpoints via @MCP, resource decorators. The client resolves concrete URIs like weather //London/current by routing to the configured server determined by the weather // prefix, which handles parameter extraction and content generation. The same templating pattern applies to tools and prompts, using call tool and get prompt, respectively, with all capabilities established during the initialization handshake.
Hash access the generated content. Print whether content 0. Text. Hash assuming text JSON response.
This accesses the first item from the documented list response of read resource. The @MCP resource decorator on the server defines URI templates like weather//city/current, where the client's configuration maps the weather / prefix to the appropriate server. While the response format is standardized as a list for consistency across all resource types, the actual content structure depends on the server's implementation, here assuming JSON text in the text field. FastMCP resource URI pattern. The @MCP resource decorator enables server-side URI templates like weather//city/current, where the server automatically extracts parameters and handles template matching during client requests. Resource URIs are server-specific, with prefixes weather//resource/ configured in the client's MCP server configuration, allowing clean namespacing across multiple servers. The documented read resource method always returns a list, even for single resources, requiring 0 indexing to access content, while the initialization handshake establishes all available resource capabilities up front.
The prefix that divides the servers unites the protocol.